Hi friends, this is Syed Reshma Sharif. In this video, we are continuing this video with the previous video. Frequency domain sampling and reconstruction of discrete signal. In previous video, we have discussed till here, okay. This is nothing but for an expanded equation of x of 2 pi by n into k. That is x of 2 pi by n into k is equal to summation of n is equal to minus n to 1 x of n e to the power of minus j 2 pi by n k into n plus summation of n is equal to 0 to n minus 1 x of n into e to the power of j 2 pi by n into kn plus summation of n is equal to from n to 2n minus 1 x of n into the e to the power of minus j 2 pi by n into kn for n is equal to n is equal to n to 2n minus 1, okay, up to an infinity. Here this is called an equation 3. Now this equation is expanded version for the above equation. Then equation 3 will be written in this form. The this equation is compact version we are going to write, okay. Compact version of equation 3, that is x of 2 pi by n into k is equal to summation of L is equal to minus infinity to infinity summation of n is equal to ln plus n minus 1 x of n into e to the power of minus j 2 pi by n into kn. This is a compact version of equation 3. It will be represented as equation number 4. Okay, in this equation, if you observe, L is ranging from minus infinity to infinity. L can take a values from minus infinity to infinity. If you take L is equal to 0, then in this case, the summation will be n is equal to 0. The term will be n is equal to 0. Then we will get an above term. If we put L is equal to 1, then n is equal to n to 2n minus 1. Okay, so we are writing this equation in this form, okay, by compacting. If you compact means it for writing purpose it is very easy. So we are compacting this above third equation to fourth equation by putting n is equal to n minus ln, okay, whereas ln is equal to n minus n. What we will get, ln is equal to 0 and ln is equal to ln is equal to 0, okay, by putting ln is equal to 0 and ln is equal to n minus 1 in the above equation, then what we will get, x of 2 pi by n into k is equal to summation of, by putting L is equal to ln is equal to 0, ln is equal to n minus 1 in above equation. Here we will get this equation summation of L is equal minus infinity to infinity, summation of n is equal 0 to n minus 1, x of n minus ln e to the power of j 2 pi minus j 2 pi by n into k. Let us rearrange this equation. We can write, after rearranging this equation, I am going to write an equation x of 2 pi by n into k is equal to summation of n is equal to 0 to n minus 1, summation of L is equal to minus infinity to infinity x of n minus ln into e to the power of minus j 2 pi by n into kn. Okay. Here, this term is represented as a periodic signal with a period of n. We can represent x of n minus ln as x of pn. This is a periodic signal, so we can represent it x of n minus ln as x xp of n. Okay. Frequency domain sampling and reconstruction of discrete time signal. Okay. Next one is frequency domain sampling and reconstruction of discrete time signal. Here x of 2 pi by n into k is equal to summation of n is equal to 0 to n minus 1, summation of L is equal to minus infinity to infinity x of n minus L minus n into e to the power of minus j 2 pi by n into kn. We already told that periodic signal, which is x of n minus L minus n, is written as xp of n. What was x? P of n. For periodic signal, after placing n minus L minus n as xp of n, then the equation will be written as x of 2 pi by n k is equal to summation of n is equal to 0 to n minus 1, summation of L is equal to minus infinity to infinity x p of n for a periodic signal into e to the power of minus j 2 pi by n into kn. Okay, this is equation number 5. It is represented as equation number 5. Okay. Let us call this equation as a discrete Fourier transform equation. What we will call discrete Fourier transform equation. Using Fourier series, x p of n is equal to summation of k is equal to 0 to n minus 1 a k. This is a Fourier series. We are going to use this one. Okay, e to the power of j 2 pi by n into kn for 0, for n value range from 0 to n minus 1. Okay. This is written as equation number 6. This one is a discrete Fourier transform equation as equation number 5 and this one as equation number 6. Then AK can be written as 1 by n summation of n is equal to 0 to n minus 1 xp of n into e to the power of minus j 2 pi by n into kn. Here this value range, k value ranges from 0 to n minus 1. Let this equation will be number 7. AK is a Fourier coefficient. Let us compare this equation number 7 and equation number 5. I am going to compare this equation number this one and this one. Okay. By comparing these both equations, we can write the value of AK is equal to 1 by n x of 2 pi by n into k. All this term is written as x of 2 pi by n. Okay, I am going to write this equation. For k values ranges from 0 to n minus 1. Let us put these values of AK in 8. Here, let us put the value of AK value in equation number 8. Then xp of n is equal to summation of k is equal to 0 to n minus 1 1 by n into x of 2 pi by n into k into e to the power of j 2 pi by n into kn. This is equation number 9. This equation represents an inverse Fourier transform, inverse discrete Fourier transform. Okay, this equation represents an inverse discrete Fourier transforms. Okay, now equation number 9 gives the construction of a periodic signal from samples of Fourier transform xp of n from the sample of x e to the power of j omega. This topic is very important for your exams. Thank you for your watching.